Let's look at question 4. The question says, below are the graphs. F of x is equal to x squared plus bx minus 3. So this is a parabola, okay? And g of x is equal to a over x plus p. This is an hyperbola. F has a turning point at C, so there you see, and it passes through the x-axis at x is 1. So that's the x-intercept of the parabola. Then D is the y-intercept of g of x and f. Okay, so D is the y-intercept of the parabola and the hyperbola. And then the graph of f and g also intersect each other. So this is the points of intersection. That is a point of intersection, and that is a point of intersection. Then it says the vertical asymptote. So the vertical asymptote of the hyperbola passes through this point. There, it passes through x is equal to 1. So that's the asymptote of the hyperbola. Eh? So that p is this number over here, just the opposite sign. So if this is a positive 1, then we know that p is a negative 1. 4.1 says, write down the value of p. Write down the value of p. 4.1, p, that p over there, is the vertical asymptote. So p is negative 1, the opposite sign. So far, we have y is equal to a over x minus 1. Then 4.2 says, show that a is 3. So show that a is 3. And show that b is 2. B is over here. A is over there. I think let's start with the hyperbola. We have this so far. And if you highlight the hyperbola, let's highlight quickly. So there's the hyperbola. Let's highlight. I need a point on the hyperbola. The only thing I do see is that this D, D is the y-intercept of F and G. So if I look at F, here's F. So F, if you write it down, looks like this. It's in standard form. So when a parabola is written in standard form, this over here is the y-intercept. So 0 and negative 3 is the y-intercept. So this D is 0 and negative 3. So that D I can sub into the hyperbola because it's on the hyperbola. So I'm going to write that down. So I'm going to write D is equal to 0 and negative 3. And then I'm going to say, let me sub 0 and negative 3 into y is equal to a over x minus 1. So now I'm just going to change it. So wherever there is a y, I'm going to write negative 3. So negative 3. And wherever there's an x, I'm going to write 0. So 0 minus 1. Then I'm going to solve for a over negative 1. So then I'm going to cross multiply negative 3 times negative 1. I get my a to be positive 3. So there it said, show that a is 3. Then it says, show that b is 2. I just need a point to substitute. So on the parabola, I'm going to substitute this point. That point is 1 and 0 because it's on the x-axis. So I'm busy with 4.2. So I'm going to write down what they gave me for the parabola. And then I am going to sub 1 and 0. So my y becomes 0. My x becomes 1. 1 minus 3. 0 equals 1 plus 1b minus 3. b is equal to 1. Negative 1 plus 3. So I get b to be 2. And there b is 2. So let's look at the next questions. 4.3 says, calculate the coordinates of C. C is the turning point of the parabola. So, turning point I can derive. So, I'm going to derive for my turning point. So, when you derive that, you get 2x plus 2. Okay? Then I'm going to take my derivative. and make it equal to 0. And then I'm going to solve for x. I get my x to be negative 1. And then to get the y value, I'm going to sub this into the original. So y is equal to, this was the original parabola. And then I just make the x negative 1. Calculator, and I get this answer to be negative 4. So C is negative 1 and negative 4. So another way to do it, you can use this formula, x is equal to minus b over 2a for turning point A. So x is equal to minus b is this number there over 2a. A is this number there. So if there's no number, it's 1. This is negative 2 over 2, negative 1. Okay, and then you take the negative 1 and you sub it into the parabola, and you also get negative 4. So this was just another way of doing that question, right? I'm going to just write in C. C was negative 1 and negative 4. And then this D was 3, negative 3. 4.4 says write down the range of f. So if a parabola has a smiley face, then the range is y is greater than or equal to the y value of the turning point. And if it's a sad face, then y is less than or equal to the y value of the turning point. Now we have a smiley, eh? So y is greater than or equal to the y value of the turning point, which is negative 4. 2 marks there. If you want to rewrite this, or you want to write it in a different notation, you can write y is an element of any number between negative 4, square bracket, to infinity, round bracket. So you can decide which one you want to use there. Eh? The next question says, determine the equation of the line through C. So there's this line that goes through C that makes a 45-degree angle with a positive x-axis. Okay. Write your answer in the form y is equal to. So let's make an example here. C is over here, then the line is going that way. Then this is C. Then they say, you see this angle is 45 degrees. This is the x-axis. C is negative 1 and negative 4. They want the equation of this line. So to get the equation of this line, this is 4.5. We know the equation of a straight line is y is equal to mx plus c. So because we have this angle of inclination, we can work out the gradient. So tan theta is equal to the gradient. So tan theta is 45 degrees is equal to the gradient. On your calculator, tan 45 is 1. The gradient is 1. So far, I'm going to replace this in here. Y is equal to 1m or 1x plus c. And then I have to substitute a point on the line. Now, it said the line goes through C. So I'm going to substitute C. Negative 4 is equal to 1x. Oh yeah, x is now negative 1 plus c. Negative 4, negative 1. And this is the negative 4 plus 1 is c. I get my c to be negative 3. So the equation of the straight line is y is equal to 1x and then minus 3. 0.6 they ask, is the straight line that you determined in question 4.5 a tangent? Explain your answer. Now, our equation of the straight line was this, eh? So now we need to find out, is this a tangent? Now, if you look at this graph, eh? If you look at this graph, do you see this negative 3? Isn't this negative 3? So it means C, that line will go through C and D, because the y-intercept of this straight line is -3. So the straight line will go like this. That's how the straight line will look like. And can you see it touches the parabola twice? So then no, it's not a tangent. So you'll say no, it's not a tangent because the straight line goes through C and D. So it's supposed to only touch once, eh? So you can see it goes through C and D. Another way you could have answered that question is, remember if a line is a tangent by C, because this line goes through C, if it was a tangent, the tangent should have looked like that. That's how the tangent should have looked like. So let's make the line straight, like that. Because this is the turning point, and at the turning point, the gradient is 0. And the gradient of this line was not 0. The gradient of that line was 1. So let's look at the last question, 4.7. So 4.7 says h of x, so h of x is equal to f of m minus x plus q. Let's write this down. H of x is f of m minus x plus q. And this new graph only has one x-intercept where x is 0. Now, x is only 0 there. Determine the values of m and q. So they want to know what's this m and what's this q. So h of x is a transformation of f. So f is the parabola. So this parabola has been transformed. So let's figure out what happened to f. Okay, so the first thing I notice is the fact that normally, so let's write, normally when you transform a graph, let's say it shifts left or right, and there's a minus. If it was a plus, the order doesn't matter. But if it's a minus, it was supposed to look like that, not a minus x. So I am first going to rewrite this h of x. So I'm going to write it like this. If, then I'm going to take the negative out. Then inside the bracket, I'm going to switch around. So switch around, close the bracket, and then plus q. So this is the same as this. So 3 transformations happened here. Do you see this negative inside the bracket by f? That means the graph was reflected. So that means it was reflected in the y-axis. Then this minus m over here means it was translated, so it shifted to the right. You see, minus means to the right and plus means to the left. Okay, so that also happened. And then, do you see this q over here? It shifted q units up. So there was 3 things that happened. So when you reflect a point in the y-axis, the x value changes signs. So the new x is on this line. This is now 1, a positive 1, and -4. Okay, so the parabola will look something like that. Now, the goal is to get the parabola, the turning point, to be here, from here to there. But remember, to get from here to there, I must move left, right, up, and down. If I move 1 unit to the left, I'm on the y-axis. Do you agree? And then if I move 4 units up, let's use another color. If I move 4 units up, I'm at the origin. So I reflect it. Then I'm going to move 1 unit to the left. And then I'm going to move 4 units up. Okay, this m over there is 1 unit to the left. So if it's to the left, it must be x plus 1. So to get that to be a plus 1, remember left is plus, So at the moment, it's x minus m. So it must be x minus, then this is -1. That will give me an x plus 1. So m is -1. That means the graph shifted 1 unit to the left. And then this q is straightforward. It's 4 units up. So that is what's going to happen to that graph. Okay, question 5. We are still on functions. Question 5 says, sketched below is the graph f of x is equal to k of x, where k is a positive number. So k is greater than 0. And then it says 4 and 16 lies on f. Okay, so there we see it is on f. And 5.1 says, determine the value of k. Let's do 5.1. So I'm going to write the function down. Y is equal to k to the x. And then I'm going to substitute the point on the graph. So I'm going to substitute 4 and 16. So y is now 16 and x is 4. Now I need to solve for k. So there's more than one way, eh? So the first way is to get rid of this power. So I do the fourth root, but what I do on the right, I do on the left. So I get my k to be 2, eh? Plus or minus 2, but it said here k is a positive number, so k is 2. That's one way. Another way is to, let's replace this quickly first again. We can't make the base numbers the same, but we can make the powers the same. So this is to the 4. So 16 can be written as 2 to the 4, so that the powers are the same. And once the powers are the same, they fall away. K is equal to 2. So there's more than one way of solving that, eh? So our function is 2, y is equal to 2 to the x. That is the function, eh? Let's go to the next question. 5.2 says, graph G, so there's this new graph. Graph G is obtained by reflecting f. This is f. So our graph is f. By reflecting f in the line, y is equal to x. So that means this is going to be the inverse, eh? This line is the same as the inverse. Determine the equation of G. So I'm going to write f down. I'm going to do the inverse. So I'm going to swap the x and the y. So can you see? You get a mark for swapping. And then I'm going to make y my subject. So y is equal to the log. My base is this base, and the x goes there. So there's my 2 marks, eh? So g of x is the log of 2 to the x. 5.3 says, sketch G and indicate on your graph 2 points on G. To sketch the inverse, I'm going to take the original graph. So do you see there's a point and there's a point on the original. So I have x values and y values like that. So I have x is 0, then y is 1. That's this point. Then this point is 4 and 16. So then I'm going to use just another point. Let me use negative 1. So if I sub in negative 1, I get my y to be a half. So there. Okay, so this is the original graph, right? This is f of x. So to do the inverse, I'm simply going to swap these points around. So negative 1.5 becomes a half and negative 1. 1 and 0, 16 and 4. And then I'm just going to plot those points. You can use any points, eh? So I'm going to use a half and negative 1 somewhere there. 1 and 0, 16 and 4 somewhere there. So then this graph will look like this. They wanted 2 points, so 1 and 0. And this point, if this is 4 and 16, this one is 16 and 4. And there you have g of x, just like that. Okay, let's look at question 5.4.1. Over here, it says use your graph to determine the value or values of x for which f of x times g of x is greater than 0. Okay, so with this one, I'm going to do a little table. So I'm going to do f of x. Then I'm going to do g of x. And so when they multiply or divide the functions like this, and there's a 0, Remember, you must use the x-intercepts, eh? So f of x is this one over here. F of x doesn't have x-intercepts. But g of x has an x-intercept, so it's 1. That's all. So f of x, I'm going to ask myself, is the graph above or below the x-axis, eh? So let's move from here up until forever, actually, eh? This graph is always above the x-axis. So I'm going to say before 1 and after 1, it's always above. Then for g of x, I'm going to say from left to right. So from here to here, it's below. So below. And then from here to here, it's above. So it's above. Okay. Then I'm going to multiply the two. I'm going to say a positive times a negative is a negative. And a positive times a positive is a positive. And because there was a greater than sign, I'm looking for the positive, eh? Here's the positive. Here's 1 and onwards. So my answer is, it is where x is greater than 1. And that's the answer to that question. Then the next question is, for which values of x is g of x less than negative 1? So where is this graph g less than negative 1? So somewhere here, the y value is negative 1. So what will be the x value there? What I'm going to do is, I'm going to take my inverse graph. So my inverse is this. And I'm going to let y be negative 1. Because I want to see what's the x value at that point. I'm going to rewrite this as 2 to the negative 1 is equal to x. So I get my x to be a half. Here, x is a half. So now the question is, for which values of x is this graph below negative 1? From here onwards. But remember, there's a line here. This y-axis, the graph will never cross this line. My final answer is, it is where x is less than half, but it is also where x is greater than 0, because on this line, x is 0. It's from here till forever, closer, 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 but it will never hit 0, eh? And because there's an equal sign in the question, I have an equal sign here, but not an equal sign here, because this 0 is an asymptote. So it will never touch. So there can never be an equal sign next to an asymptote. And so that is the final answer there. Point 5 says, if h of x is f of negative x, calculate the value of x where this minus that is equal to 15 over 4. We are going to solve for x, eh? Let's quickly work out what's h of x. So h of x is f of negative x. So wherever there's an x, I'm going to change the sign. At the moment, f is this. Now, h of x is just that. Now they say we have to work out this over here. I'm going to write this down. I'm going to say f of x minus h of x. Remember, this is h, eh? This is h. And f of x is the function that was given to us, eh? So now they're saying that minus that gives me this. What is x? What I would do is, I would rewrite this as a positive exponent. 1 over 2 to the x is equal to 15 over 4. Then I'm going to let 2 to the x be k. I'm going to say let 2 to the x be k. This becomes k minus 1 over k equals 15 over 4. Now I want to get rid of the denominators. There's a k and a 4. So I'm going to multiply every term by 4k. So k times 4k, this k times 4k is 4k squared. This 1 over k times 4k. This k and k will cancel. This will just give me 4. And then 15 over 4 times 4k. This 4 and this 4 will cancel, so this will give me 15k. Standard form is 4k squared minus 15k minus 4 equals 0. And then I'm going to factorize and solve for k. You can factorize or use the formula. If you factorize, remember when you use the formula, you're solving k, eh? Let's factorize 4k and k. And then I'm going to have a 4 and a 1. I'm going to have the 4 here and the 1 here. This is a plus and this is a minus. I get my k to be negative a quarter or a positive 4. But remember the question was to solve for x, not for k. Remember 2 to the x was k, so 2 to the x is this. Or 2 to the x is this. You can't make the bases the same with a negative number. And here we can make the bases the same. So I get my x to be 2. And that's how you solve that question. If you can't factorize, use the quadratic formula. So that's how you would solve that question.